Welcome everyone. So today we're going to discuss about virtual work. So virtual work in classical mechanics is the hypothetical work done by forces on a system during an imaginary infinitesimal displacement, which is virtual displacement, not a real change in position used to analyze equilibrium or dynamics. This concept of virtual work is one of the important concepts in classical mechanics because it's help us to analyze a system with many degrees of freedom, and also for systems in complex equilibrium and dynamics. So it will help us to eliminate those constraint forces and do the calculations in a simplified way. Now we're going to define virtual displacement. So the position of the ith particle is in general function of all the generalized coordinates, that is q1, q2, qn, and time t. So if r be the function of q1, q2 and time, then the total differential of the position of the ith particle dr is del ri by del qj into dqj summation j from 1 to s del ri del t into dt. But in case of real displacement it happens over a finite time, but in case of virtual displacement it is instantaneous and imaginary, so only this term will survive. So in case of virtual displacement, dri is equals to del ri del qj into delta qj summing over j equals to 1 to s. This delta qj is our virtual displacement. Now the principle of virtual work. The principle of virtual work states that for a system in equilibrium, total virtual work done by all external forces is zero for any virtual displacement. So this is our principle of virtual work. Now we're gonna see what it is saying mathematically. A system of n particles under time dependent holonomic constraints. Now the virtual displacement of the ith particle dri is del ri del qj delta qj summing over j equals to 1 to s, as we have seen from our previous calculations. Now if the system is in equilibrium, then the total forces acting on each particle is 0. So Fi is 0, which is the forces applied on ith particle. I can be 1, 2, 3 up to n for n particle systems, and for the virtual work done by Fi in the displacement delta ri is Fi dot delta ri, which is equals to 0 again. Now the total work done delta w is summation I Fi dot delta ri, which is equals to 0. Now the forces on ith particle is two types of forces. One is applied forces and another one is the forces due to constraint. Then we have delta w, which is equals to summation I Fi. Now we're going to put the value of Fi in this expression. So we will get summation I Fi applied dot delta ri plus summation Fic, that is the forces due to constraint, or delta ri, which is 0. Now in case of virtual displacement, the forces of constraints do not do any work, so delta w is equals to summation I Fi a dot delta ra. Here Fi a is the applied forces. So this is the principle of virtual work. So now from the principle of virtual work, we have this delta w is equals to 0, or summation I Fi dot delta ra is equals to 0. So we can use this condition to derive equation of motion and also the condition for equilibrium for complex classical mechanics problems, and we can simplify our calculations. So this was our discussion on virtual work and the principle of virtual work, and on our next class we're going to discuss about Lagrangian and D'Alembert's principle. Thank you everyone.